So this is Getting Started with R. I'm Christopher Cameron. I'm a computational scientist at the Cornell University Center for Advanced Computing. So today is about getting started in R. Maybe you're a postdoc and your PI collaborator has sent an R file, and you've been handed this R file and your PI has asked you to replicate the analysis using your own data or something like that. So maybe you haven't used R very much before. Maybe you've come from SPSS or Excel, and you haven't really delved into R yet. You've heard of it maybe, and you need to figure out how to get started. What is R? What does the universe around R look like, and how do you get started using R to do useful things? So we'll talk about some basic R concepts, how to install R in RStudio, some of the essential elements of the RStudio interface, and then look at a few examples of loading and summarizing data. And like I said, there's more examples available for you to look at as self-study in this R project that I'll share. R does take time to learn, and if this is your first step, I know it can be a little daunting at first, and so that you be kind to yourself. It's a learning process. We're here to help you get started. The next workshop in this series is November 29th. It'll be data analysis with R. I'll be going over a few examples. If you have examples for data analysis in R that would be particularly useful to you or people working in your field, please get in touch. I'd be happy to include those. So R is a software for statistical analysis. It is good for things like tabular data or vectors or lists. It's good for statistical analysis and data visualization, and it has quite a few facilities for interfacing with custom code written in maybe C or Fortran. It's less good, I think, for unstructured data, although that is changing. There's quite a bit of interest in dealing with text data in R. So those features people are building them out, so they're becoming more available. I wouldn't use R for things like file system scripting. If you wanted to automate the handling of files on your operating system, you could probably work it out, but it's not really ideally suited for that kind of work. It's a sort of medium for data scraping, cleaning, and formatting. I myself prefer Python for that kind of work, and then I moved over into R for the statistical analysis and modeling. There are people that want R to do everything, and so you can probably find packages to do most things you want. It's not always advisable or the best idea, but you can. R has a lot of capabilities. So to understand R, it's helpful to know where R came from. R was designed by faculty members of the University of Auckland. They wanted a better software for their teaching laboratory. So R at its heart was a tool for teaching stats. These two professors didn't like the commercial offerings available, but they did like this S statistical programming language that was available at the time. But they wished that it had some of the modern language features that they've seen in other programming languages, like a Lisp variant called Scheme. And so R started as an implementation of S with some extra features added in. And then they mailed it out to their colleagues, and their colleagues liked it too. And eventually they were persuaded to open source this R program back in 1995. So it helps to understand that R was built by people who really like to do stats. They like to teach stats. It has a non-commercial kind of origin, and it's shared in open source. And as it was shared, R became used and supported by a community of mostly academic researchers. And more recently, like in the last probably 5 to maybe 10 years, 5 years especially, R has been picked up by data scientists as well. R gains new features through packages that are developed by users, people in the community. There's over 10,000 add-on libraries in R now. That's a huge space to keep track of and understand. Luckily, there are some helpful documentation that say, okay, what's your field? And then here's some R packages that are popular in your field. So these R packages are developed for specialized research areas. It's a way to implement and share cutting-edge statistical methodology. So when you're developing a new methodology, you probably implement it in R and share it with your small discipline first. and then maybe later it'll be moved into other software packages, but R is the place where it's developed and tested. There's an official package collection. I put the link there. You can have a look at it. There are additional package collections. So Bioconductor is a package collection that's for more biology and bio, what do we call it? Computational biology is the focus for Bioconductor. So you could, if you're looking in that discipline, you'd probably go to the Bioconductor repository. It's also possible to load packages directly from GitHub. That's becoming increasingly popular. So instead of, in order to be listed, to have your package included in an official package collection, it needs to build on every platform that is supported. If you have a more specialized package that really only needs to run on one platform, it's becoming more popular to just distribute it through GitHub. So I don't have an example of installing from GitHub, but if I know it's possible, and I could look it up for you if need be. In addition to having all these academic researchers who are developing for R, there's also an active community for teaching and learning about R. And blogging about R. So I put a few links to some of the, I think, better resources. There's people who will help you one-on-one in a community forum. R bloggers is an aggregator for blog posts about using R and for a variety of disciplines. And they sort of do a best of a wide range of blogs. So it's a good place to look for, to understand about new techniques. Now, with this many people developing for R has become, it's a bit eclectic. And that means that, so when people write R code, they bring their own background to writing R code. And so they will adopt styles that are meaningful in other languages, but not meaningful in R. So you'll see a lot of cases where there's dots in the middle of the name. So there'll be like maybe this is your model, and this is some part of your model, and it'll have a name like this. And it really implies by its structure an object-oriented design, but really R does not assign any special meaning to it. So you'll see this, if you're coming from Java or another programming language, would look like there's an object, and then there's a member to that object. In R, that's just a name. It doesn't imply any special structure. There's many conventions that are pulled in from other languages. So things like initial caps or camel case or snake case or variables with dots in the name. Those may have meaning for other languages, but they don't in R. So there's no special meaning assigned to those. So sometimes you'll read R code and you'll think that just by its syntax, you'll think that it just sort of means something, but it only meant something to the author that wrote it. R doesn't have any special. It doesn't have any special interpretation for these things. So you will see a lot of different styles mixed together in R code, and for better or worse. The packages that are developed, they tend to work very well for the expected input, but they can be unpredictable with incorrect input. Researchers don't always program defensively, so they program it to work well with the input that they expect it to take. They haven't worried too much about what happens if people misuse their code. Usually for R, there are many ways to accomplish any given task because people will be inspired by different programming paradigms or from just different programming languages, and they will have brought those models or those patterns of programming into R. But despite all this, R is focused on practical productive use. So it does some nice automatic things like type conversion. There are a variety of convenience features that many people like, but aren't actually good practices, like mixing everything together in one global namespace, which if you don't understand what that means, that's okay. And the other one is there's this attach function that lets you features are organized into packages. When you attach a package, it puts all of the functions that you can call into what's called the global namespace. So if you have two packages that use the same names and you mix them together in one space, you can no longer tell which for any given name, you don't know which package it's coming from. So it'll warn you about conflicts. It's a little bit messy, but somehow it mostly works out for people, despite these things. So I will discourage you from using attach, and we'll talk about next time how to be careful when you're importing things into your global namespace. But it has a consequence of these convenience features. Sometimes packages mask each other's functions. You'll get a warning about it, so it's not like you don't have any chance to know, but you might not understand what that error message means. We'll talk about that more next time. You can use variable names and give them the same names as functions. Sometimes people who are starting off in programming will do that. It makes your code very hard to read, but in R, it actually still works. So the first So when we talk about using R, it means a couple of different things. There's base R, which is a open source project that is maintained by the R Foundation. And it is a command line interface where you use R through this R console. You type commands, and that creates objects in memory rather than printing them to the screen. So you type a command, and it changes your computer's memory, puts a thing in there. And then you can query that object in memory, and you can manipulate it. But you don't ever really see it. You can print out results of models, but the model lives in your memory and you don't really look at it. So it's interactive in the sense that you get this thing that exists in memory. You can query it and you can interact with it. So it's interactive in that way, but it's not interactive in the point and click sense. So that feels really different from when you're using something like Excel, where you see all the data right there in front of you all the time. So I say many people that use R don't use base R directly. Instead, they're going to use something that interfaces with base R. The most popular one is the RStudio development environment, and we'll take a look at that a little bit later. So when you install R, all of these, no matter what interface you use, you have to install base R first. So I think it's a little baffling when if you're not familiar with R or software mirrors and you come to install it, you think you go to the download page and you click install, and the first thing it comes up with is choose a mirror. And all a mirror is a copy of the R Foundation's code kept somewhere closer to you. So basically, different institutions have agreed to serve as a mirror. And so people that live close to that institution should download their R software through that institution's mirror. If you don't want to have to think about which institution is closest to you, you can go to cloud.rproject.org and it'll find a close mirror for you. This also comes up when you're installing packages. I think it's off-putting, I think, to people that haven't encountered it before. That you'll get a list of like 85 things, and you have to choose one. And if you're not sure what the considerations are, that's a little daunting. Choose something close. And if you see cloud.rproject.org as a choice, you can just choose that, and I know it will be taking care of the details automatically. So if you go to cloud.rproject.org, you'll get a page like this. There'll be download links for different platforms. You download this, it's a double-clickable installer. It'll run, and then you'll get an R program on your computer. If you open it, it's going to look like this. Essentially just the R console. There's a little prompt here, and you can type commands. And that's, might say, why would I even want this? And a lot of people feel the same way. This is the base R. After this, you usually put something else on top of R so you can use it without having to just stare at a command line. So when you're using R, you adopt a different mental model than you would if you're using SPSS or Excel. R has this idea of a workspace or an environment, and it's in memory, and that holds your data tables and your results. You don't really look at your workspace, although RStudio fixes that a little bit. But these objects exist in the memory, and you can manipulate them using R commands. And um, more precisely, those R commands are functions. So you'll type commands into the R console. You'll load data that way. You can apply statistical functions, and you can produce output. Most of the commands actually don't produce output. You have to ask for the output. So that's displaying the output is usually its own separate command. So for instance, when you fit a linear regression model, all the model fit can happen with nothing printing out. You have to then say, I want the summary of that model, and then you can see the results of that model fit. So in contrast with something like Excel, most of the time in R, you're looking at the commands that describe what you're going to do with the data, and not the data itself, and not the results themselves. Um, people like to have a little having most of your code or most of your data and most of your results kind of being in an invisible space is a little bit hard to think about for a lot of people. So a different model came about, and this is computational notebooks. And computational notebooks started with this idea um, that wouldn't it be cool if documentation and code were sort of treated like literature? And this was a computer science idea back in 1984. Computer scientists and software engineers in particular, didn't really care about this. Why would we do this? It wasn't interesting to them. But mathematicians kind of like this idea. Mathematica, the software, implemented an idea of a computational notebook around 1988. And people doing math research really like this idea of a document that had both the computation and the documentation sort of interspersed and mixed together. And other research disciplines liked it too. And it moved beyond just having your code documented into a research narrative. So in addition to saying this is how you use this code and here's the code, we also talked about why you'd use the code and what using the code, like the results of using the code and what they meant. And so people started to use computational notebooks to construct a research narrative. And we talked about this back in a couple sessions ago, and we talked about Jupyter Lab in the cloud. And this same idea is present in R as a computational notebook. So we call this Rmarkdown is the original notebook format in R. Then RStudio has introduced a new RStudio, or I guess Posit now. Posit, the company, has produced an updated version of Rmarkdown called Quarto. And Quarto extends Rmarkdown, but is not R specific. So it also works with, for instance, Python and Julia and JavaScript. So let's see, we'll talk about Quarto in a moment. So think about components of a research narrative. You'd have sort of an organizational structure, titles, subtitles, or headings, subheadings. You'd have code. You might have plots. You have maybe some math, and you have sections of prose. And just these are all elements of a narrative. In a computational notebook, you can think about putting each of these different components in its own cell and then organizing them into a sequence. And that's what a Jupyter Lab notebook does, and that's what an Rmarkdown notebook does, and what a Quarto notebook does. So that's what we mean when we say computational notebook. The extra interesting part is that any cells that involve computation are executable, so you can run them right there in the notebook. So if you want to share your notebook with someone else, they can reproduce the analysis live right in the notebook. So Quarto is a unified authoring framework. It's from the folks who developed RStudio. RStudio has included Rmarkdown for quite a long time, about a decade. And they wanted to build on that experience and say, well, now that we kind of understand how people like to use Rmarkdown and what it's good for, can we build a tool that's maybe a little broader? So it's not R specific anymore, and it supports more output formats like Jupyter Lab. notebooks, for instance, can also convert to Quarto, and then from Quarto you can go to a variety of output formats. You can make web pages, you can do PDFs, Microsoft Word, ebooks, LaTeX articles if you're publishing maybe to Archive or one of the journals that accepts LaTeX. You can make LaTeX presentations, and I forgot the X there. You can export to either Beamer presentations or to PowerPoint presentations. JATS is a journal format that it's meant to represent all articles. Like any article is supposed to be representable in JATS format. So all these output formats are available once you get your document into a Quarto format. I know that they'd like to add support for interactive dashboards. So you can, if you've used something like RShiny, they'd like you to be able to write an RShiny style app using Quarto and then export to that format. Quarto supports things like citations and figure references. All of the elements that you need for regular academic publishing are supported by Quarto. So it's designed with publishing in mind, academic publishing in particular in mind, and it's an exciting development. A lot of these things have been available through Rmarkdown if you include extra packages, but they're trying to make one tool that will do all of it, and then make that tool available in other languages as well. So if you are a person like me who uses both Python and RStudio, learning Quarto makes sense because you can learn that one tool and use it in both places. So I mentioned RStudio. RStudio is an integrated development environment for R. It depends on you having a pre-installed version of R already, so you have to make sure you install base R before you install RStudio. It is an interface built around that R console. So you still have an R console, but you have a lot of other sections too. We'll look at those in a moment. Interesting news coming up. Posit, the company, is going to incorporate Python compatibility into RStudio. It's already available in their commercial, their paid version, the RStudio Workbench. I don't know if it's going to come to the free version, but they are showing Posit, the company, is showing quite a bit of interest in Python. And for instance, they hired the developer that wrote the Pandas data frame library recently. So I expect that Posit, that RStudio, as it migrates to Posit Studio, is going to be both R and Python based more and more as we go forward into the future. It's probably part of why they want to develop Quarto, so they have one unified authoring tool that supports both of the platforms that they're interested in. Posit as a company is they are interested in data science, and they were trying to, I think, bring some of the most popular tools under their umbrella. They're a public benefit corporation. I think it's great to see people putting resources into both R and Python. So I'm interested to see how this all develops. You can, let's see. You can install Posit. I think I have a link for it. If you don't want to install R and RStudio locally, you can use the cloud version of Posit, which looks just like the desktop application. I shared a link. I'll share it again. If you'd like to register for a Posit account, then you'll be able to follow along in a little bit once we look at some demos. But this is they have a free tier, which is the one you should sign up for, and it'll give you several hours a month of free hosted computation. It's a good way to explore RStudio. So if you're going to install RStudio on your own machine and not use the Posit, the Posit cloud version, here's a link that you can go to download. There, as you scroll down, you'll find lists of links to various platforms and installers. Make sure you have base R installed first. And once that's done, you'll have something like this. This is the RStudio interface. It's divided into panels. There's resizable dividers between the panels, so you can rearrange your interface. And there's four main sections. There's the editor, which is the upper left. There's the R console, which is the same as it is in base R. This is essentially base R lives down here in the lower left. Then there's two tab panes that provide extra information. I think the most popular use for the upper pane is going to be the workspace viewer. You can actually see a list of things that are living in your computer's memory. The things that are put there by R at least. And on the lower pane, one thing is the file browser, another thing is the plots. So this is the basic RStudio interface. You'll use the R console just like you would if you were using base R. You can type commands here, you can run them, you can view their output, and you can use the up and down arrow keys to navigate your command history. So if you need to repeat a command, you can press the up arrow, or one or multiple times, depending on how far back you want to go in your history, and it'll show you, it'll cycle through your command history, and you press return to execute whichever one is showing. Our console is good for exploratory analysis and maybe testing your commands. Not really good for documenting your analysis or making a repeatable analysis, because you'd have to type it all out again. Most people who are using R now use the R editor. They might write scripts, which is a .r file, or they might create a Quarto or Rmarkdown documents. It also has, in addition to having a place to write scripts or write notebooks, it has a data viewer. So it looks like a data table. It's not good for editing, but it is a good way to get a sense of what your data looks like if you are used to Excel and you kind of miss seeing your data. In contrast with the console, this editor is a good place to document your analysis and to write a repeatable analysis, because you can create a script that's a sequence of commands, or you can create a computational notebook in Quarto or Rmarkdown that's not just a sequence of commands, but a sequence of commands interspersed with explanations and interpretations of the results. Both of those are great things to share with a collaborator. So for most people, they're going to be working up in this upper window in one of the editors. And you can, if you have a whole script, you can execute the whole thing, or you can execute line by line if you want to kind of step through a sequence of commands. So in the editor, in the tab panes, you'll have things like the workspace or environment viewer. There's a data import wizard that we'll take a look at. There's your command history if you don't want to tab back through it. Links to tutorials, which those are worth checking out. Posit is investing a lot in our education, so I recommend visiting their tutorials. On the lower pane, there's the file browser, the package manager, which we'll look at, and it's one of the places that you can display plots. It's not my favorite because it's a kind of small section of the screen. I'd rather just put them inside the notebook, but a lot of people like to look at plots in the lower pane over here. So a few R concepts, words that you'll hear that are worth understanding. R always has a kind of working directory, and where it will try to read and write files from that working directory. And it used to be that you'd always set your working directory before you started to work, but R has moved on to I think a better model of having a project. And you say start a new project, and you choose a directory for that project. And then everything related to that project kind of lives in that directory. And it keeps track of more than just your working directory. It keeps track of your packages and things as well. So rather than worrying about setting a working directory all the time, I'd recommend that you create a project and keep all of use that as a way to control where your working directory is. It's easier to share projects, and then the code written to share that inside of that project. We'll just assume that it's next to the data files it needs or near the data files it needs. So if you zip up that folder and share it, that code will run on another person's computer. So this idea of a project and using projects is a good idea. You may hear that in R. Another term is packages. I mentioned before that there were like 10,000 add-on packages for R. Some other, in Python, we might call these modules or libraries. In R, they're called packages. So it's a collection of functions, often includes data, most importantly, it includes documentation about those packages, and all that's bundled up into one thing called a package, and that adds extra functionality to R. You'll hear about R script files. You may have even received one, in an email. Please replicate this. It's a sequence of commands in plain text. It'll have a .r file extension. Other common types of data files associated with R are the computational notebooks. So either the Quarto, which is the QMD, or the Rmarkdown, which is the RMD. There's also there's a file extension for data as well. I don't like to keep data in proprietary formats, so I always export to something really plain and machine readable like CSV files. One of the best things about R is its documentation. It has good built-in help. If you look up the help entry for a function in R, it'll have a description of each function available and the arguments that you used when you call it. It'll have examples showing how the function might be used, and the best ones also have references to the relevant either manuals or academic papers that talk about the methods that those functions employ. So if you're a person who cares about doing stats right, I recommend reading the references in the documentation. You'll get a in-depth discussion of some of the considerations behind this particular method. I've learned a lot of stats by reading the reference section in R help. The documentation for packages. So typical help entry is for any function, including built-in functions. When you have a package, it'll also have documentation, and it includes the descriptions, examples, and references, but also it includes vignettes, which are they show you how to use this package to complete an analysis. So it's a great way to learn how the author intends for you to be using their package. I remember I mentioned earlier that our packages tend to work well with expected input and unpredictably with unexpected output or input. So you should check out the vignette to see how the author intends for their package to be used. There's usually some data sets bundled in with the package that help support that vignette, so you don't have to go out and download or find your own data. You can use the bundled data. Vignettes are a great way to learn about a new kind of analysis. You'll get a package for maybe sequence analysis, and you want to understand, like, how am I supposed to use this to analyze my data, and how do I interpret the results? And then vignette will walk through those steps. Here's how you load it. Here's how you plot it. Here's an analysis. This is what it meant. It's a great way to learn in R. I wish that vignettes were more widely adopted and available in Python, because it's a really helpful feature for R. I've said this word functions a few times. Functions are the primary way that you use R. A function is a command. It takes an input and it probably returns an output, but not always a visible output. A function will take the input to a function is called its arguments. It takes one or more values that we'll call arguments. When I say calling a function, I mean we're telling the function to operate on the arguments. So examples of how this might look are down here. So there'd be the name of the function, and then some parentheses and the argument. So if it has one argument, it'll be parentheses around one item. So this would be some value. if there's multiple arguments, it'll be either a comma separated list of arguments, or sometimes a function might have 20 arguments, but only one of them is required. And if you want to change how it operates on that argument, you provide a named argument. You can optionally supply this. So this might be a flag that sets something to false. So occasionally, often you'll see named arguments. So it'll be the name of the argument and then equals some value. And so this function, this example has two arguments, the first one, and then a named argument as a second argument. Here's an example of a real function call. This is asking for the mean of a column of data. In this case, the name of that column is column. We'll see some examples where we're using real data frames and real names. But this is when I'm talking about functions, this is what I mean. It's very different from Excel, where you might highlight a range and then say, what you do, you click in a cell, you type equals, and then you choose the function, and then you choose a range that applies to it. So I guess it's fairly similar in the sense that in Excel, you get a kind of menu of functions that you can choose from. I guess R has a similar idea here, where there's this range there's a variety of functions, but R has a lot more than Excel. Another concept that's important in R, probably less present in Excel, is the idea of a variable. That's a way that we store and use values in the workspace. So a variable is a name and a value associated with it. And we use that name to represent that value when we make a function call or do operations on it. So if you add two variables together, then the result is the result of adding their values together. You can restore values that are returned by function calls into other variables. So you can operate. So you can do a width and a height, and you can multiply. You can have one variable called width and one variable called height, and you can make a new variable called area by multiplying those two values together. When you create a variable in R, you need to use an assignment operator. R has two operators. Actually, there's more, but these are the two that do kind of the normal thing that we'd expect. And for historical reasons, it has this arrow hyphen operator that used to correspond to a button that was available on keyboards a long time ago. Now we have to use two characters to type it. You can also use just an equal sign to assign. So this says I want you to make a variable called width, and I want you to assign it the value of 20. Next line says exactly the same thing. I want to make a variable called width, and I want to assign the value 20 to it. I like the equal sign because that's what it is in Python, and I'm already used to it. Some organizations have their own style guides. I know Google style guide says you should use this less than hyphen symbol for assignment in R. So you can check with your organization and your lab for the appropriate style. If there's no style guide in place, I think the equal sign saves you a keystroke. Operators are kind of the normal mathematical operators. You might be familiar with this. They can be functions, but we often refer to them as operators because there's a familiar subset of mathematical operations like addition, subtraction, multiplication, and division. Listed a few here. You can find these through the help, but it's, I think, useful to know which operators are available. Most of them are the same as they would be in Python. There's also a set of operators for operating on logical values. So you can negate if X is true, then not true is false. There's two types of logical operators for or and. This one returns true or false. It's good if you're using it in a conditional, like if if this and this are true, then do this other thing. So this only returns a true or a false. With a single pipe or a single ampersand, it will compare two vectors pairwise. So it'll compare the first two elements, the first element of each array, then the second element of each array, and the third element of each array, and it'll give you back a list of true or false, which is useful for other types of comparisons, but really not what you want if you are trying to do a condition in an if statement. So I just want to point that out. If you're making a conditional operation based on a true or false value, you should be using the double operators. There's also comparing values. Probably familiar with all of these. This is how you represent them in R. It is the same as the way you'd represent them in Python. When you're using R, you'll spend quite a bit of time worrying about data types, and that should be the case in all the languages that you use. In Excel, you don't get to worry about it quite so much, but it often will convert your data types for you in a way that you didn't want. I think one of the common things that happens is when you have genomic data and you put it in Excel, it'll convert some of the gene names into dates. And that's terrible for your analysis because it's not even a one-to-one mapping. There's more than one. Some genes will go to, I guess more than one gene will go to the same date when they're converted. So if you put your data in Excel and export it, then some of your genes have been combined to a single symbol, and that's not great. So we always want to worry about data types. R doesn't. I haven't run into that problem of collapsing genes in R, but you do want to make sure that you have the right representation for the type of value you're using. It impacts the types of summaries you'll get or the types of output you get from R. So common types, numeric, like integers or floats, Boolean values, character values, which are strings, and then categorical variables that look like strings, but we've told R that this can only take on a few values. It's not any string, it's only a certain subset of strings. And once R knows that something is a factor, it treats it a little differently. It gives you it behaves differently in models when you're doing model fit, and it behaves differently in summaries. There's also date times if you'd like to represent a particular point in time. In R, we do most of our work with data frames. This is that classic table structure, just like you would use in Excel or a CSV file. Typically, rows are cases and columns are variables. So all the values in a single column are going to be of the same type, but different columns can have different types. You can have a string type, or you can have a factor type, and you can have a float type. There's a few other similar data structures. There's data frame. Data.frame is one from base R. There's data.table, which is good for representing large data. And then there's Tibble, which is like a data frame, but a little more modern. It avoids some of it has less convenience features to avoid gotchas. That's its main advantage. You can access an individual column in a data frame by using its column name. So this would be, if this was called data frame and I wanted to get the calcium, I'd do data frame $calcium, and that would pull out the calcium column. A few other concepts. You may hear of vectors. These are basically a list. You create them using this C function, and you give it a list of things, and then that'll turn it into a one-dimensional array of values. They're all the same type. Lists are the other important ones to know about. when you fit a model, you get back an object that's very much like it acts like a list, a named list. So I say I'm making this thing called mylist2, calling the list function, and then I give it a comma separated list of name value pairs. So there's an item called message, an item called yesterday, and an item called width in this list. And I can retrieve those particular things by using their name. So my list $message is I like R. And you have a model and you want to get your residuals out of it, it's going to be the model name $residuals, and that'll give you your list of residuals, for instance. That's why it's important to know about lists and list-like syntax. Won't deal with those today. Many packages. So there's many packages for many different disciplines. You don't need to use pure R. Please make use of the packages that help streamline your common operations. Feel free to use other packages if one package isn't good for your particular application. One set of packages I highly recommend is the tidyverse. I'd say that the tidyverse it's written by Hadley Wickham, who's I think still the chief data scientist at Posit. He wrote it before he was hired by Posit, and then Posit hired him to continue the development. I'd say that this set of packages probably saved R from Python dominance. It's a pretty important set of packages. It's the modern R set of packages. So I'd recommend trying learning more about these. We have a little time to look at some examples in Posit Cloud. So I have a link here to go to the Posit Cloud content. I'm going to share that also in chat. Do you have to install the packages every time you use R? Not typically. You usually have to install them once, and then they'll be on your machine. If you move to let's see, when would you have to install them multiple times? If you're using a cloud-based solution that doesn't keep a persistent environment, like you're using EC2 and it spins up on demand, and it's not your environment, it's sort of a clone of an environment, then you would have to reinstall the packages. But mostly once you get it set up the first time, it's good to go. I'm going to switch my screen share real quick, and then all right, so this is Posit Cloud. This looks remarkably similar to, yeah, it's a good question. I'll get to that in a moment on the updating packages. So this looks remarkably similar to what RStudio will look like on your local environment, except it has this little extra sidebar here. And I didn't close it because it's so great. If you're trying to learn R, please have a look at these things under Learn. I love the cheat sheets. They are dense printouts that you can keep right next to your keyboard, covering some aspect of R. So you want to know about Quarto syntax, or you want to know about, let's see, Reticulate lets you use Python inside of R. I would look for the one on dplyr, for instance. But these are extremely helpful. Their recipes are code examples, and their primers are short lessons. The primers are going to go away after the end of this year, so take a look at them soon if you'd like to see them. But I recommend having a look at these things. They invest a lot in teaching how to use RStudio, so it's worth it to take advantage of those efforts. All right, here's our interface. We have our console, a blank editor. We have an empty environment, so there's nothing in it. And then we have our lower one with our list of files. You should see the same list of files if you load this project. These are the ones I put in here. How do you know about updating packages? So if you click on packages, you can click update. And since I updated yesterday, there are no updates. But this is where you'd go to the packages tab and then click update. And if you want to install a new package, you can use this little wizard to do it. You can also, there's also a command line way to do it, but I think I already have, should have tidyverse on here already. Let's see. Yeah, looks like it's done. Okay. So let's put some things in our environment. So today I'm using a Quarto document, which, where is it? There we go. Actually, I should open this one too. All right. So one thing if you haven't used R before and you're learning R because someone has asked you to replicate an analysis, you probably got something like an R script, which might look something like this. It will require some packages. It will it'll load data somehow, and then it'll do some stuff to that data, and then maybe you do a basic analysis. So the way to look at this file is understand it's a sequence of commands that are run from the top to the bottom. So that means that the command at the bottom probably depends on stuff that happened earlier on. If you're trying to understand what this is doing, take a look through for function names and use the help. You can search for those things. Use the help to understand what that's doing. So this is saying this factor function, we can read what it does. It's used to encode a vector as a factor. And there's an example of how you use it. So I might, by reading this documentation and comparing to what's happening here, I can understand maybe that this is taking this data frame column called sex and turning it into a factor with the levels male and female. This is probably the best way to go about disentangling what's happening when you first receive a script, if you're unfamiliar with the functions. We can go to GLM and go, oh, okay, so this is fitting a generalized linear model. And read about what's happening here. So this is, if you're a person that just received a script, I recommend going through looking for the functions that are used in this script, and then reading the documentation to go along with them. So we'll talk about our basics real quick. Your working directory shown right here. If you're inside of a project, then it's always the project, and you might as well leave it there. If you're not using a project, you may have to set it, which is easy to do through the session menu. What we're looking at a Quarto notebook. I'm going to go ahead and collapse the. I'm going to collapse the console since we. Oops. Go away. There we go. Okay. These lines are related to Quarto. They tell it that this is an R cell, and they set some options on it. So the ones in curly braces and the ones with the pound pipe symbol are something for our Quarto, and everything after that is the R code that belongs in that cell. So this is saying I'd like to use the tidyverse package. So I could run that cell, and it will load the tidyverse package. One of the first things you're going to have to do is import data. You can use the wizards over here with the import data set. I'll do nutrient.txt real quick as an example. So this one shows you this is what the input file looks like, and based on the options you've selected, this is what the output's going to be. And that's not too bad because it's pretty clear that we've separated, all the columns are separate. This data frame doesn't have a header, so we don't actually know what the column names mean. R has generated some kind of random, some names for it, some numeric names, but they're not great. So we would use that wizard, select the best choices, and then we get a little printout here that shows us what uh, the result of the options we selected as a command line argument. So I'll jump back to here. Having run that, we now have a little. This is our data frame. It doesn't have the column names we'd like, but the data's in there. We also see over here an environment that we have something loaded. It's got 737 observations and 6 variables. If we click down, we can get details about those. The first type is an integer. The rest of them are numeric. Probably we'll want to do something like rename those columns. This cell shows how to apply a row of, or an array of names to a data frame. And if we do that, then, no, wait. Right, I'll run that cell first. So there's our data frame. Run this one, get the names on it. And this version has, the names applied, which is much better. You can also use the reader for importing data. It's a more advanced package. I don't want to take too much time on that, but I'll say there's a reader, another way to import. You can also import from these various formats. If you are a Stata user or a SAS user, you may benefit from using the import dataset wizard. The hard part on importing this registration times is that one of the columns is a date time and it's a particular format. You can read about how to parse dates by operating this cell or running this cell. It'll load the help for parsing dates. I wanted to include an example of date parsing because it's not obvious how to find the help for it. So this is the right way to find the help for it. And this is an example of a format that you might encounter. This is year hyphen month hyphen day space hour minute second. If you'll encounter other formats, but knowing that there's a set of tokens and you kind of arrange them to match the format of the data will help a lot. Oh, if you get the format right, then when you look at your data, it will show that it's a POSIT. This is a POSIX timecode format. If you don't get the format right, then instead of being a date time, it'll be a string, and that means that it's harder to operate on. We're just about out of time, so I will skip a little bit. So because we have the right data type here, this is going, let's see. Yeah, so we got the right data type for our date time, which is important. Our org column, let's just look at this data real quick so you get a sense of what I'm talking about. So it's your registration times and organizations. You can see that there's only a few organizations here, so that was probably should be a factor instead of a string. You can see right now that when I ask for a summary of my my registration times data set, the organization column is simply character type. If we change it to be a factor type, which we can do by first saying, well, what are all the unique values? And it turns out there's only 3. We can make that a factor. And then if we ask for the summary on that, instead of being unhelpful, it will be it will give us a summary. It'll know that there's 3 factors, so it'll give us the counts of each level of the factor instead of just telling us there's 266 values. I'll run through a few more demos for people that want to stick around. Let's have a quick look at this import data set using Reader. First thing, I need to choose the data set. I want to do registration times. Let's have a look at how this. So it made some guesses. It thinks that the delimiter is a comma, and it's correct in this case because it's a CSV file. I could actually, at this point, tell it that I want my organization to be a factor. But then I have to know all the values, which is why I did it in script later. And then we have the registration times, which right now are represented as a double. I wish it was a date time. But to specify as a date time, I'd have to know the right format. And you see it's given me one that would be month, day, month/day/year/space, hours, minute. That's not the format I have. So I need to type my own format here. And from reading the documentation, I know that it's I know the symbols to type. Otherwise, it would be hard to, starting from this cold without reading any documentation, it might be hard to know what symbols to type. Luckily, there's some hints there, and like I know that it's lowercase m and lowercase d, so that's helpful. So I add the hyphens because that matches the format shown in this column. So year, month, day, space, hour, minute, and second. And I can try that out. Yep, now it sees this as a date time, which is great. And then I could click, it shows me the code that it's going to use to run the import. And so I click import, or I can copy out that code. I already have that code here, so when I run it, I get a proper datetime format. We talked about detecting the unique values in this column, the organization column. That reports back that we have 3 unique values. And I can make those 3 unique values the levels of my factor, and that'll turn the organization into a factor. And I should have probably, let me just do one more thing here. Why don't we summarize it again and see how it looks? So instead of having this be a list, see right now before when it was just a string, the summary was pretty terrible. It just tells me I have 266 rows essentially, which isn't that helpful. But once I make it a factor and I run it again, now my summary is counts of the different factor levels, which is way more useful. That's one example of why setting your data types correctly early on is a very important strategy when you're using R. Because now I get a summary that is useful and makes sense rather than just a row count. So let's look at some basic. This is the nutritional data set. I believe it's nutrient levels for a variety of people. Wow, let me make this a little longer. Okay. Sometimes it comes up ugly. This is one of those times where you might rather see it in the in console. Yeah, here it is in console. A little easier when it's not getting line wrapped. So I asked for a summary of this data frame. It's telling me case ID. The summary isn't terribly important, but for calcium, it tells me that the minimum calcium level was 7.4. The max was 2,866, and it gives me a mean, and it gives me some quantiles. So that's a nice summary value, a nice way to get a quick summary of a data set. It's using the summary function. It also works for other types of objects. So if you have just a statistical model, like a general linear model, and you ask for summary on that, it gives you a summary that's sensible for a general linear model. Another function you might run. I already got this information by using the summary function. But if I want to get the mean for just an individual column, I can say, I get the data set name, $, and then the name of the column. So it gives me the mean of a particular column. often in R, you want to apply the same function to many columns out of a data frame. So this says apply to this data frame by column the mean function. It's kind of weird grammar, but that's how it is. And I could do it again. I can say, okay, apply to this data frame by column the standard deviation function. And if I do that, then I get the case ID. You just gonna, it doesn't, there's no interpretation for the mean case ID that is useful. But for all the other columns, this is the mean level of these nutrients, and this is the standard deviation for those nutrients. I am a big fan of ggplot. It's part of tidyverse. It's a plotting library based on a concept called the grammar of graphics. The idea is that you should be able to specify the graphics you want to see, and it should figure out the details for you. So here I say, I want to make a ggplot based on this data set. I want the x-axis to be calcium, and I want it to be histogram, and give it a title. And that gives me a simple plot. You can fuss with the details of these plots quite a bit to add styling. For a quick plot, I think this is great. It's fast. If I come back to this after a year, I know exactly what this plot is going to have in it. And if I wanted to change a detail, because it's using named arguments, it's easy for me to figure out what to change the appearance of the plot. So quick histograms. Here's another ggplot. This one, I want to look at the same data set, but here I want the x-axis to be calcium and the y-axis to be iron. And I want to see a point cloud, basically, the relationship between those two. So is there a relationship between those two? Maybe. We'd probably want to use a model to determine that. But this is a quick visualization technique. And once you learn to read a ggplot specification for a plot, it's easy to know what you're going to get, and it's easy to specify new ones. Real quick for categorical data, I'm going to use a data set from the Titanic. It's about the survivability of different classes of people. This data set is part of this package. So I required this package, and having loaded the package, I can now access the data frame. I guess I told you that puts it in the global namespace, like I mentioned. You probably shouldn't do this. This is still really common. I think eventually we're going to move on to importing things in namespace. So instead of having to require the Titanic, I could instead just say Titanic : and then Titanic train, and that would say, get me this. You go to this package or this library and get this item out of that package. And that's an alternative to loading a package. You can fully specify it this way. So let's have a quick look at this. So this is a data frame. It's 891 observations based on the passengers. We have whether they survived or not. That's an integer right now. Their class, like steerage or first, and the other one. Their name, which I guess we could use perhaps. The gender or sex in this case, because it's a long time ago. We have their age and some other details about where they were. And this is what this data frame would look like if we were to look at it. So this is just details about the passengers on the Titanic. So what can we do with this data? One thing we might like to do is get summaries. I'm going to use the dplyr package here. It has a function, two things. It imports this pipe operator, which is I think it gives you a nice syntax when you want to construct a series of steps to take with your data. So I'm saying take my data frame, send it to the select function, and then send the results of that to the head function, which shows me the first 5 or 6 rows. And I can do the same process again and send it instead of to head, I can send it to summary. The alternative way to if you didn't have a pipe operator, you'd have to specify it like this. Apply the head function to the result of selecting from this data frame these columns. And this, I think, is harder to come back to after a couple of weeks or a year and decoding mentally what's happening. I think this piped version is easier to keep track of, easier to read when you come back to it. Once you learn how to read it, of course. I know at first it's like, what does this even mean? But we can see when I run this. So this is showing me, this is pulling out these first 3 columns and then summarizing those first 3 columns. We'll take a quick look. And I asked for a table. I can ask for a table of the survived column. I didn't change the type of survived, so it is true and false. Or it is 0 and 1, which is supposed to represent true and false, but that's not a great summary. I could go ahead and change that. I'll change it for all these. I'll change gender into a factor. I will change survived into a factor and give it the values yes and no, and I'll make sure that we know that the passenger class is also a factor. So once I do that and then I summarize, then I get a much nicer summary. I instead of having to know that there's a 0 and 1 and knowing which one is which for sex, now they have the proper labels. I know that survived people that didn't, I can more easily and correctly read the values off this chart. That's the main point. Once you assign the factors, then when you make a data table, a summary of any kind, it's easier for you to interpret. You don't have to, in your head, kind of translate the variable value back into a meaningful factor level. It just does it for you. And then it follows through the analysis. So once again, choosing the right variable type early on, very important in R. Let's see, we'll check for missing data. There's some missing values about age. It's good to know. That actually impacts the results later on. Let's see, I'm gonna skip down. You can run these, you'll get a sense of what they do on your own, but I wanted to take a quick look at this one. So we found there were some missing values in age. And what that means is that if you try to apply a function to them, R will automatically not give you any results for the ones with missing value. It wants you to explicitly decide how you're going to handle missing value cases, because it's easy to make mistakes. If the values are missing for a systematic reason, you want to account for that in your analysis. And as a way to prevent you from making that mistake inadvertently, R does not summarize over missing values. So in order to get a value out of this summarize function, I actually have to say, and I want you to explicitly remove the missing values and give me the mean with ignoring the missing values. So the second example, you'll often have to do this to get results out of a summarize function or a mean function, because otherwise R will not believe that you're handling your missing values correctly, and it will not give you a summary. One thing to wrap up, this is fitting a small regression model on this data. So I'm going to predict your survivability by sex, your passenger class, and age. You'll probably, if you receive a file and you're told to reproduce an analysis, you'll probably see a model of some kind in there. So when I fit the model by itself, I actually didn't get anything back. I have to call this summary function on the model to see the results. The summary gives me the call that generated the model, gives me a variety of output, including coefficients. So in this case, it looks like, yeah, being female was associated with survivability. Being the because the highest value class is 3, but that's also the lowest class of passenger. This is negatively correlated. So the higher your passenger class number, meaning the lower class your ticket was, the less survivability you had. And for age, the older you are, the less survivability you had. So these are all significant, but that's a little example of fitting a model and getting some results from it.